Okay, so Mendel, when he was messing around with the pea plants and he was trying to isolate these physical characteristics that they were too tall, or they had purple flowers, white flowers, seed shape, that kind of thing. He determined that there has to be something, and he called them genes that pass traits from parent to offspring. Well, for simplicity purposes, genes are packets of genetic information. But you're going to hear me talk about them like there's one gene for this trait and one gene for that. It's never that simple. The packet of genes, like eye color alone, we're going to talk about it in notes, and it's going to be like one gene gives you this color, and it's not. I think eye color is like 25 different genes. Okay, but they do follow rules that you can kind of predict. But think about it. So genes are packets of information that deliver that genetic information that gives you whatever characteristic you're thinking about studying. Okay? In my case, I had blonde hair. Now it went dark, and then it went gray. My youngest, Eli, he's got blonde hair. What's the chances he's going to keep his blonde hair? Nah. My wife doesn't have blonde hair. Yes, she does. But it's faked up, right? She has actually dark hair. So he probably won't be dark. So that gene is going to kick in and turn off, give him that blonde. Now, let's make this very simple. Genes, right? Packets of information. If you notice, here's 6 coins, right? Penny, nickel, dime, quarter, half dollar, and a dollar coin. They're still out. People still use them. I liked them. A lot of people didn't. But wouldn't you agree? These are all money. So they're the same, right? Because they're money. But you would agree with me that they're all different, right? So I want you to remember. Genes are the same, but they're also different. And that usually blows people's minds. So when my college professor was talking about genes and how they're the same and how they're different, it just got jumbled up. Okay? So these are all the same, they're money, but they're different coins. So they have different values. So think of a gene, you think packets of information that are the same, but can be different. Okay? Blush. Now, so what? Genes. These genes carry the information that gives you the trait. So like you have freckles, you don't have freckles. Can you bend your thumb like this, or can you not? These genes are what, when they're turned on, they go to work, and that trait is expressed. Okay? So they determine, or they specify, put that in there, they specify what traits you're going to have. Now, just like I have an address, 480 West Amsel Road, Rensselaer, Indiana, 47978. You guys all have one. Genes have addresses. Their address is called the loci. The loci. Okay? And so if you look over here, here's a chromosome. And you see these like bands? These are different genes in their location. And so that would be whatever this gene is, that's its loci. And you're like, big deal. Well, you get one chromosome from mom, you get one chromosome from dad. They have to match up. So if I get one from, say this is mom, and I draw out the identical chromosome that you would get from dad, the genes are going to be found in the same exact location on the other chromosome. Follow along? Makes sense, doesn't it? You can't, let's say if it's pair, we have 23 pairs. So pair 1, the chromosomes are going to match, the genes are going to match. Pair 2, they're going to line up, they're going to match, the chromosomes are going to match. You can never have a pair 1 jumble up with a pair. It doesn't work that way. Okay, but the genes don't switch places. The genes are always found in the same location. Now, this is a little advanced. Okay? This is called the P arm up here. P arm. P stands for petite. When I say petite, you think small. Because the top P arm is usually smaller than this arm. This arm is called the Q arm. And the only scientific reason they call it the Q arm is because it comes after P. I've yet to find out anything that tells me otherwise. Okay, so P, the petite arm, and then Q is usually called the long arm. All right, and so chromosome 1, chromosome 2, they match up, the genes are at the same loci, and then genes come in pairs. because you get one gene from mom, you get one gene from dad. Think about the family that walks on all four. The kids that walked on all fours, they got a bad gene from mom, they got the same bad gene from dad. And now you know they're walking on all fours. All right? And then genes are heritable. Not irritable, heritable. What's that mean, you think? Help me out.
Hereditary.
Yeah, you can get them. They're given. You can inherit them. Just like when you have kids, if you have kids, you're going to give your physical traits. And remember, it's not always just a physical trait. It could be a behavioral trait. Things of that nature. Now, here's where, I speak for myself. In college, I was confused. Genes, alleles. That's how you say that name, allele. Genes and alleles. So let's look at this. Alleles are they're different forms of the same gene. Remember, genes can be the same, but they're also different. Alleles, just to help, you're going to hear me say it a lot. So like right here, here's an allele. But is it a gene? Absolutely. That's an allele. But it's a gene as well. It's just different forms. Now, let's give it a characteristic. Tall. Your height. You're tall. Let's say the capital T is always dominant. Right? And then if you have that, that means you're going to be tall. If you have this one, that means you're not going to be quite so tall. My dad is 6'2". I'm 6'1". My mom is 5 foot tall. I didn't get my mom's genes in that area. I think I got more of my dad's. So if you think about it, these are the same gene because they're expressing height. They're giving you your height, but they're different because this one will make you tall. This one will not make you tall. It depends on what your version of tall is. Okay? Some are dominant, some are recessive. And that's how you know they're different, because they're dominant or recessive. And we're going to get into this here in a second. Okay? Any questions so far? Okay. So if you look, here's a pair of chromosomes. The top one is your one you would get from your father. The mother gives you the one on the bottom. Here's your genes, a pair of genes, but these are also alleles. Whatever this trait is. Same thing down here. And you notice this could probably be it's hard to tell. P arm, Q arm, I don't know. And then over there's the B's. Though the B is a totally different gene than A. And we always use, in biology, we always use the alphabet because it makes it so much easier. All right? Now, the allele specifies the form that the gene takes. Okay? The allele is very specific in the form the gene takes. Is it dominant or is it recessive? Those are the only two forms. Remember, you gotta have two. You can't just be given one and it work. It will not work that way. You'll have a mutation there. When babies sometimes don't get the gene, they will self-abort. Okay? Now here's another way of thinking about it. Coca-Cola. I like Coca-Cola. If I want to clean my money, my coins, you throw it in there overnight, it'll make them shiny. It eats metal. It's an acid, right? And let's say it's a Coca-Cola gene. Look at that. Again, just driving home that genes are the same because they're Coca-Cola, but they can also be different. In this case, flavor. Here's the regular, Diet, and Coke Zero. Okay, so this would be the alleles. Okay, the gene is Coca-Cola, but these are the alleles of it. All right. Make sure you stop me if you get kind of confused, because I got to keep you here. Okay, finishing it up here. Alleles. Here we go. Remember, I told you we're going to take genes. We're just going to say one gene equals one trait, one gene equals the next one, whatever trait we're talking about. Much more complicated than this. But let's say two capital B's, which we call, and you'll learn this later, homozygous dominant, because they're both dominant. Here you have a dominant with a recessive. This one's called heterozygous in its genotype. And this would be homozygous recessive, right? And so if you have a big capital dominant B and you get a little lowercase recessive b, these are the only three ways they could ever be mixed and matched. Okay? And so if you look at that capital dominant B, it's a dominant trait. Always listed in uppercase. And when I say it, masks recessive. So if whatever trait, this is the dominant. I'm going to make my hand the dominant trait. My hand is out here, it's real big. The recessive, I just make a fist, and then if I can hide it behind my hand. It's just like that. So you can't see the recessive, so it's hidden behind the dominant. If it wasn't for this dominant, we would probably not be here because there'd be mutations, just like the family that walks on all fours, they got a recessive mutated one and another recessive, and so they had to walk on all fours. But if their parent would have given them just one dominant, they would have masked it and they would be normal. They'd walk normal. Okay, so remember that. Dominant just means it masks it, so you can't see this one, but you can see this one. It's expressed. Okay, and so the trait, let's say the trait for capital B is brown eyes. For dominant B, brown eyes. Now the reason I mentioned that, they use that one because the number one eye color in the world is brown. Number one eye color is brown. I think like 3/4 of the population has brown eyes. If you have blue eyes, you're like one of the rare ones. That's a mutation that started about 10,000 years ago in southeastern Europe, and it stayed in the population because they thought it enhanced a person's look enough that it would help them find a mate. Okay? I don't have blue eyes. I used to, don't anymore. But that's a recessive trait. Now, recessive is the lowercase. Okay, and it's always masked. Remember, if it's in the presence of a dominant one, it's going to take second fiddle every time. Every time. Every time. And for a rule, remember, capitals are always written first. All right, so if you have that recessive, the little recessive B, that's going to equal blue eyes. Now I'm going to put this up. We're just about done here. So if I have a person and I check his genes or her genes and they have homozygous dominant, what color's their eyes? Brown. Look at this one. If a person's heterozygous, what color eyes? Brown. Because this one covers this one. Okay? And then here, there's no way this person ever going to have brown eyes. So here's your blue. So what would happen if I would cross two people with this genotype? Would they ever have any children with blue? There's no way possible that they could ever do it. Ever. Okay, what about if you cross two people with this genotype? Big B, little b with a big B, little b. Could they have children with blue eyes? What do you think? Yeah, they definitely could. They definitely could. And if you may even have that kind of situation in your family where your mom or dad has brown eyes, but you have blue. And your mom has blue. You get the idea. And if you have two of these, there's no way possible they could ever have brown. Okay? And when we get into the Punnett squares, you'll be able to do them just by sight. You won't even have to write. You'll just do a Punnett square by sight. Okay? Any questions? All right.